today's topic is tree. Tree is a non-linear data structure that stores the data in parent-child manner. So tree is basically a collection of nodes or vertices and edges. The nodes are useful to store the data or contain the data element that we want to store in the tree, and edges are useful to connect the nodes. Let us now check various terminologies related to tree. For that, let us draw one small tree here. As I have told, there will be parent-child relationship. There should be one root from where we need to start. Suppose we want to store data A inside a tree. As no tree is there, so this is the only node in a tree, so it can be treated as the root. And if there are more other data, then the root should be treated to the first node of a tree. Now the second one is parent. Any node should be treated as parent of its very next descendants. Suppose we are having two other data called B and C. Now B and C are descendant of A, or more specifically, they are very next descendant to A. So B and C must be told as the child of A, and A should be treated as the parent of B and C. Now the fourth one is sibling. What do we mean by sibling? Sibling is the brother or sister from same parents. Here also B and C, they are having one single parent, that is A. So we can say B and C are two siblings. Now descendant. A set of nodes which can be reached from any particular node are called descendant. Suppose in this example, from B, where we can reach? From B we can reach to E, we can reach to F, J, K and M. So all these nodes are the descendants of B. Another term is ancestor. For any particular node, all the other node, those come in the path of root, and that node is called ancestor. Suppose we want to reach to O. Using which path we should go? We can reach from A to D, then D to H, then H to L, and then L to O. That means these all nodes are the ancestor of O. Now come to the degree of a node. The number of direct children any node is having is called the degree of that node. Suppose in this small example, A is having 2 children. That means the degree of A is 2. Now come to this big example. Now A is having 3 children here, B, C and D. So degree of A should be 3. Similarly, degree of H should be 1, degree of L should be 2. Now external and internal nodes. External or internal nodes are also called as leaf node or non-leaf node. Leaf node are the last node that are not having any children. Suppose in this example, M, E, K, N, O, I, G, they are not having any further children. See here also, they are not having any further children, so they can be treated as the leaf node or external node. All the other nodes that are having at least one children are treated as internal node. So we can say the external node can have degree 0 and the internal node can have degree greater than 0. It can be 1 or more than 1. Similarly, level and height. Always remember, level for any tree start with 1, whereas height for any tree start with 0. Now forest. What is a forest? A collection of trees are called forest. Suppose in this example, this is a tree, right? So A is the root, A is having left child as B, right child as C. Also, B is having some child. Now what if we just remove A and also these edges? Then This B, it is become one tree. Also for C, this is become another tree. But they are not the same tree, right? So these two are together can make a forest. Now after the basic terminologies, let us now go through binary tree. What is a binary tree? Binary tree is a type of tree that offers degree 2. That means a binary tree can have less than 2 children but not more than 2 children. So a binary tree can have maximum of 2 children, and the left subtree of binary tree is called the left child. Right subtree of the binary tree is called the right child, or what we can say, left subnode. So what is the left subnode of A? B is the left subnode of A and C is the right subnode of A. So B is the left subnode of A, so it can be said as left child of A. Similar way, C can be treated as the right child of A. Now binary tree can have no children. Okay, for leaf node no children should be there, like this D, E, F and G, they are not having any children. Similarly, some node can have only one children also, and some node can have two children, and that is the maximum. In a binary tree, any node cannot have three children. Now let us go through some example and check whether they are binary tree or not. Okay, let us check for the first example. Okay, root is having two children, so it is having two children, so degree is 2. Now its left subtree or left child, it is not having any children, so the degree should be treated as 0. Now right subtree, here it is also having two children, so degree of its is 2. Similar way, the left child is not having any child, and right child is not having any child, so they are also having degree 0. So this tree is having only degree 2 and degree 0, so it can be treated as binary tree, right? So it can be treated as binary tree. Similar way, now let us look at this tree. Okay, this is having only left subtree, so degree is 1. And this left child also, it is also having one left child, so degree is 1. And the last node or the leaf node is not having any child, so degree is 0. Okay, as it is having degree 1 and 0, this is also can be treated as binary tree. And whenever in a binary tree only left subtree is there, that can be called as left skewed binary tree. Similar way, when a binary tree will have all the right child, that can be said as right skewed binary tree. Here also it is having degree 1. But for the fourth example, the root is having 3 children, and that is not acceptable in case of binary tree, so it is not a binary tree. Let us look at the fifth example. Is it a binary tree? Yes. So if we can treat this as a root, it is having 2 children, left and right. The left child is also having 2 children, left and right. And the right child is also having 2 children, left and right. So all the nodes are having degree 2 and 0. It is also a binary tree. Now, in a binary tree, maybe some data can be there or maybe some data cannot be there. So we may store some data in a tree or we may not store some data in a tree. Whenever we store some data in a tree, that is called as level node. Whenever we do not store any kind of data but only take a tree structure, that is called as unlabeled node. Here all the examples are of unlabeled node. Now suppose we are having 3 unlabeled node, right? So 3 unlabeled node is given to us. Now using these 3 unlabeled nodes, how many trees can be generated? Okay, first one, we can generate one left skewed binary tree and also one right skewed binary tree. Is there any other way possible that we can make some binary tree? Okay, so first one is left skewed, right skewed, it is done. Now we can, instead of taking left subtree of left child, we can take right child also, this is also possible, and just the mirror image of it, it is also possible. Or what we can make, we can take 2 child of a root. Is there any other way possible? Okay, no. Only 5 ways are possible. So for 3 unlabeled node, we can make 5 different trees. So what about 4? If we have node 4s, how many trees can be possible? Should we draw? Or if we have 5 nodes, how many different tree can be possible? So okay, for node 4, what we can do? We can do all left skewed, or what we can make, we can, instead of taking the last left subtree, we can take the last child as right child also, or we can make a jumble order like this, or we can take only a left tree and then all the right child. Also we can take left and right child and then left of left child, or left of right child also. Or what if we can just take left and right child of left child of root? That is possible. Is there other way possible? If you see, we can just make all the mirror image of the images given here. So here we are having 7 images. That means if we take all the mirror image, there will be total 14 different binary trees. So now for 3 it was 5, now 4 it is 14. What about 5? If we have 5 nodes or 5 unlabeled node, how many binary trees can be possible? So by drawing it is quite unrealistic or impossible to draw all the possible trees. For that, we must have some formula. The formula is Tn equal to 2n Cn by n plus 1, where n is the number of nodes, and this formula is called as Catalan number, and this is the combination formula of Catalan number. Now let us check. So what about 3? So if n equal to 3, how many tree can be generated? 2 into 3, C3 by 3 plus 1. It will give answer 5. Similarly for 4 also, it will give 14. And in the similar way, we can generate, if we have 5 number of unlabeled node or 6 unlabeled node, we can find out using this formula how many binary tree can be generated. Now let us go for label node. What if we are having only label node? So for each label we are having any data 1, 2 and 3. 3 nodes are there and 3 nodes are having data A, B, C. Now for unlabeled node, what we can make? For 3 unlabeled node, 5 different shapes can be generated for binary tree, that we already shown. But in how many way we can store this data? Let us take an example of left skewed subtree or left skewed binary tree. Now in this binary tree, in how many way we can store A, B and C? Let us check. Suppose first of all we can make A as root, B as the left child of root and C as the right child of root. Similar way we can change the left child of root and we can make C as the left child of A and B as the left child of B. Similarly we can rearrange all the data and total 6 different shapes can be possible if we have only 3 data. Now for one figure or for one binary tree, we can keep the data in 6 different ways, or we can say as 3 factorial ways. Now how many different binary tree can be possible? 5 different binary tree can be possible if we are having only 3 node, and for each node or for each binary tree we can generate or we can keep the data in 3 factorial way. So total how many trees can be generated for label data? Catalan number into the number of node factorial, that should be 2n Cn by n plus 1 into n factorial, where this 2n Cn by n plus 1 should give us the number of shapes can be generated using the number of nodes, and n factorial will give us how we can fill the data in that binary tree. That is all about the shapes and shapes for label and unlabeled node. Now let us go for height and node. So how? So the question is, if we know the height of a binary tree, can we find out what is the minimum number of node or maximum number of node possible for that binary tree? Or if we know the number of node, can we find out the minimum height of that binary tree or maximum height of that binary tree? Okay, let us check. Suppose we know the height. Okay, suppose we know the height of a binary tree 1. So as you know, height of a binary tree start from 0. So minimum how many node can be possible for the binary tree of height 1? We can have a node as root at height 0. Now as height 1, so we must go to the next level. So at that next level we must have at least one binary tree, at least one node we should have. So minimum 2 nodes are possible if we have the height equal to 1. So what is the maximum number of nodes possible if the height is 1? So for a binary tree, it can have maximum of 2 child. Any node can have maximum of 2 child. So minimum 2 nodes are required. But for fill this binary tree at level 1, how many nodes are possible? We can take only one right subtree. We can only take one right child. Now if we take another node, we can take it either as the left subtree or right subtree of left child, or left child or right child of the right child. But at that time the height should be increased by 1. That means if we only have height equal to 1, at that height 1 only 3 maximum node can be taken. So if the height of a binary tree is 1, the minimum number of node possible is 2 and maximum number of node possible is 3. Now what about 2? What about 2? Okay, if the height is 2, that means we must have at least 3 nodes. As a binary tree can have 0, 1 or 2 children, so let us take one root. For increasing the height by 1, we must add one node here. Now to increase the height by 1, we can add another child. It can be left or right child. I have taken left child here. You can take right child also. But to increase the height, we must add at least one node. That means for height equal to 2, we need at least 3 children. Now what is the maximum number of children possible if we have height equal to 2? So we must fill all the nodes, or we must fill all the required gap. So every node must have 2 children. So every node, if every node is having 2 children, that means how many total number of node possible? For height 0, 1 root. For height 1, 2 children of the root. And for height 2, 2 children for the left child of root and 2 children from the right child of root. So total 7 nodes are possible. Now what about 3? Okay, let us take the left skew tree only. For height equal to 3, the minimum node or minimum node is taken as 4. What about maximum nodes? So we must take all the left child and right child for each node in height equal to 2. That means here we are having 4 external node. So 4 external node means we must have 8 external node for maximum number of nodes. So total number of nodes should be 8 plus 7, 15, right? Now let us have some conclusion here. Now if you see, for height equal to 1, the minimum number of node required is 2. For height equal to 2, the minimum number of node is 3. And for height equal to 3, the minimum number of node is 4. Or what we can say, for height equal to 2, minimum number of node is 2 plus 1. So the minimum number of node is, if the height is n, so what is the minimum number of node? What is the minimum number of height? So minimum number of node in a binary tree should be 1 greater than the height. So if we are having node n, so it should be height h plus 1. If we are having one binary tree that is having n number of node and height is h, so n should be equal to height plus 1. As you can see, for height 1 it is having 2, that is 1 plus 1. For height equal to 2 it is having 2 plus 1. For height equal to 3 it is having 3 plus 1. So for height equal to n, it should be height plus 1. For n number of node, it should be h plus 1. Yes or no? Okay. Now let us find out the relationship between maximum number of node. How the maximum number of node is coming? Okay, let us take the tree. Let us take the height is 3, and for at height 0, how many nodes are there? 1. In this level, how many nodes are there? 2. In this level, how many nodes are there? 4. Okay, let us make it 2 square. Okay, let us make it 2 square. And for this level, how many nodes are there? 8. So make it 3 square. Now how this 15 we obtain, how 15 is obtained? So 1 plus 2 plus 2 square plus 2 cube, thus we got 15 number of nodes possible in height 4. Isn't it like GP series? What was GP series? A plus AR plus AR square plus AR cube and AR to the power k. It was equal to AR to the power k plus 1 minus 1 by R minus 1. Now let us rewrite the formula for tree. Okay, here just match the number of match these two equations. So here 1 plus 2 plus 2 square plus 2 cube. Okay, can we make 1 plus 1 into 2 plus 1 into 2 square plus 1 into 2 cube? Is it possible to make? Okay, we can make it, right? Now just check what is the value should be for a. A is just being denoted for 1, so we can make a equal to 1, and we can rearrange the value of r as 2. So if it is so, then how the formula should be there for binary tree? So for binary tree, the number of maximum node possible should be represented as 2 to the power h plus 1 minus 1 by 2 minus 1. Yes or no? So it can be again rearranged by n equal to 2 to the power h plus 1 minus 1. So now compute if we are having the node equal to 3 and check whether 15 is obtaining or not. Okay, for 3 it is 15. Okay, now check for 2 it is coming 7 or not, or for 1 it is coming 3 or not, or for 4 what should be the minimum number of node and maximum number of node. If we know the height of a binary tree is 4, what should be the minimum number of node and what should be the maximum number of node? Okay, try to find it. Similarly, suppose we know the number of node, what should be the minimum height and maximum height? Okay, a binary tree can have minimum 0, 1 and 2 number of child. So minimum height should be, how minimum height should be there? Okay, we can take one root, we can take the left child, and also we can take the right child of that binary tree. So as 3 nodes are there, so the height can be minimum 1, or how many, what should be the maximum height? Let us take as left skewed or right skewed. I have taken a right skewed, you can check it for left skewed also. The maximum height can be 2 for any binary tree. So how this is being obtained? Or for suppose n equal to 7, we know n equal to 7, how these 7 nodes can be rearranged in minimum height? So we can take one root and we can take his left and right child. Also this left and right child can have one left and right child. So the 7 nodes can be rearranged in height 2. And if we just take each node at each height, then the maximum number of height can be 6. So now let us find out the formula or the relationship between node and height. So what is the maximum number of height? If we are having n equal to 7, maximum height is 6. What is the maximum height if we are having number of node as 3? It is 2. What is the maximum number of, then what is the maximum number of height should be there if the node is 15? So if you see, this 6 can be obtained by 7 minus 1. This 2 can be obtained by 3 minus 1. So here the height can be obtained 14 as 15 minus 1. So if we know the number of node is n, so we may find out the height as n minus 1. So the maximum number of height possible for any node in binary tree should be the number of node minus 1, and it is converted using n equal to h plus 1. It is converted using n equal to h plus 1. Then how this minimum height is being obtained? Minimum height is obtained from the maximum node possible. The maximum node possible. Okay, let us find out h, or let us derive h from this formula. How we can derive it? Okay, so the formula is like this. The formula is like this. Okay, now let us derive it. So if we derive 2 to the power h plus 1 should be equal to n plus 1, right? So take this 1 from right side to the left side. Now if we omit this 2, we should take one log in the right hand side. So h plus 1 should be equal to log of n plus 1. And now h can be obtained using log of n plus 1 minus 1. Okay, let us now verify this formula. Okay, now let us verify the formula for a n equal to 15. If a n equal to 15, then what is the minimum number of height? So the height should be log of n plus 1, that is 15 plus 1 minus 1, that is log of 16 minus 1. So what is log 16 base 2? It is 4. So 4 minus 1, that is 3. And maximum height possible is h equal to n minus 1, that is 14. So the conclusion is, if we know the number of node can go from h plus 1 to 2 to the power h plus 1 minus 1, and the height of a binary tree can be from log n plus 1 base 2 to n minus 1. That's it.